This video is all about 5.4, which is the binomial theorem. We're going to see a lot of this and mention his name quite a few times. We learned about the Pascal triangle in 4.4, and we see that the two lines correspond to each other starting from row 0. 5.4 is all about expanding a plus b to the exponent of n, where n, c, which is combinations, is 0 as the first term, a would be raised to the exponent of n, and so on. And as we go on, we can see that a subtracted by to the exponent of n minus 1, you get b. Then as you go on, a decreases the exponent and b's exponent also increases. And finally, your last term should be nc n bn, where a is not included because it would be raised to the exponent of 0, which would make it a regular 1. In short, a plus b inside brackets raised to the exponent of n can also be written as what you see on the screen right now, which is the sum of all the combinations multiplied by a raised to its exponent multiplied by b raised to its exponent. Now, we can see from the equation above, r is mentioned 3 times. R equals to 0 at first, and it's also mentioned in combinations. And to find the exponent of a, you need to do n minus r. But to really find the value of r, you just have to look at the variable b, and r represents the term number when looking back at Pascal's triangle, which is this guy over here, or this guy. To draw the triangle if you need help visualizing it. Example 2 is asking you to simply expand. Here it gives you the expression of 2x minus 1 raised to the exponent of 4. We know that the exponent 4 means that in Pascal's triangle it would be row 4. Here 1, 4, 6, 4, 1 are the values that are in row 4. This would be your coefficients when writing the actual expression when it is expanded. Now, we know that the a value is 2x, and you will start off with the exponent of 4 because that is what n is. And as you continue on, you can see that the exponent value of a decreases, but the exponent value of b does increase from 1, 2, 3, 4. And the last term, like I said before, was going to be ncn b value raised to the exponent of n, which is a 4. And a is not included because it would be raised to the exponent of 0, which would give it a value of 1, multiplying the whole term by 1, which would just give you the same value. You will continue on until you have the whole expanded expression simplified. When solving a question, it is possible to get a negative exponent as a result when having a fraction as the a value or the b value, like shown below. Example 3 is factoring using the binomial theorem. It would give you the simplified expression, and we can see here that there's 5 terms. We are going to make it into the a plus b in bracket to the exponent of n form. We know that there's 5 terms, meaning that there's going to be the exponent value will be 5. The first term is an, so a must be 1. Next, the final term is 3210. Well, 32x raised to the exponent of 10. Pardon me. So we can see that using our mental math in our head, the b value will be 2x squared because 2x squared raised to the exponent of 5, knowing that the exponent will be 5 in the original expression, we will see that b is 2x squared. Therefore, the final answer would be 1 plus 2x squared raised, all of it raised to the exponent of 5.